Guys, welcome back again. Now, on the previous tutorial, the thing that we saw that we were able to define a list as an input for our STAN algorithms by adding only two more arguments, referring to another level of the hierarchy. We talked about the different levels of the CDR that we have. We noticed that we had 4 different levels of the CDR. And also, we saw that we had to incorporate, oh, by the way, I have to also put the comma there. And also, we noticed that we had to just give an index, an ID, to each participants in our study that it just tags them as to what level and what stage of the Alzheimer they are belonging to. For example, by adding as integer at the data $CDR, essentially, we are just giving that an ID as an index to each 373, I should say, observation, that each observation belongs to what stage of the Alzheimer. If this is stage 1, stage 2, stage 3, stage 4, depending on the number of the CDR as a cognitive test that they have undergone before. Okay, however, now we are just at the stage, let me close all the apps, which just pops up. At this stage, what we plan to do is that to create the STAN file. In order to do that, I'm not just going to start from scratch, because I just wanted to show you that the systematic approach by adding level by one level. Then I'm just going to just copy paste all the, I should say, the blocks from the previous model and add as an adjustments the required entries for the new level which I have defined. In order to do that, I'm just simply going to the file, open a new file, and open a text file. In the text file, I'm just going to copy paste the latest model in the STAN which I have created, which is going to be model CAD. I'm just going to copy it and bring it back there. Copy paste it at the new text file which I have. At the new text file which I copy paste these blocks, I'm simply going to save it as with a STAN file at the same folder which I have created all the things before. I'm just going to call that model D, AD standing for the Alzheimer, but more importantly, I make sure that I just give the extension as a .stan to that, and by doing that, you see that we should have the colors of the fonts in my STAN file completely different. I'm just going to start from the data block to see that what arguments I do need to just add in order to make my model compatible with adding one more level of the hierarchy, which is going to be the level of, I should say, the stage of the Alzheimer. There should be, as what you have noticed, there should be a one-to-one correspondence between whatever we define as the list for an input of our STAN model with the data block which I create in a separate model. We see that we have added 2 more level arguments, which they are namely C and CDR. And I'm just going to add these 2 levels to the previous one. The first object is going to be C with the semicolon. I'm just going to add the description, which refers to the levels of the CDR, let's say the levels of AD within CDR. I know that I have to define what is that. I know that's going to be an integer. The lower of that, it can be 1. Because we have 4 stages. The patients that they are demented can belong to any one of those stages then. Now, the other thing which needs to be added when I go back to look at the data list which I have created on the R, it's going to be the indexing or tagging on the ID which I have for each observation. I named it there as CDR. I'm just going to do the same thing, but I'm just going to give it as with the length of the N. However, it's going to be referred to as the ID which shows the stage of AD to each observation. And I know that it can be an integer also, but as an integer, it can be from lower 1 goes to the upper as it's going to be the C, the level that we defined before. I know the tag which I'm just going to give them. It can be either 1, it can be either 2, or it can be either 3 or 4, which shows that the severe stage of the Alzheimer. And by doing that, I get for each observation a tag depending if they are dementic and also what stage of the Alzheimer they have been identified with. And now, I make sure that as long as the data block is complete, by adding 2 more arguments to that, I make sure also I save it there, not to lose anything in the way. Also, within the parameters also, we are just going to have one tiny change. The change that we are going to have essentially is exactly as the thing that we just had it for, let's say, for the U. We are just going to define another variable, I'm just going to call that W, which W shows the distribution exactly as what we had before. The distribution of the random slope and intercept for CDR levels. Then as a result, as what you saw before, it forms a matrix which it comes with 2 parameters inside. The first one is going to be number 2, means we have 2 rows, and we have C columns. C, you remember, C was 4. But what do we mean by that? We mean that we have 2 rows. The first row refers to changing the intercepts, and 2 refers to the changing the slopes. Now also, remember exactly as from what we had before, we have to define a vector with the length of the C that refers to the standard deviation that we have from those changing and randomness from our 2 values. What I'm going to do, I'm just going to define, I should say, for example, a sigma. I'm defining sigma W because W represented, I should say, the matrix which contains the random, I should say, the changing, the different, I should say, measures that we had for the slope and the intercepts. But the sigma refers to the standard deviation. I say that standard deviation for W, which we know that it has to be now. It has to be a vector. We know that it has to be a positive one. That's why I just add the argument as W. But because that's a vector and it has to just adopt a length, we just go with the length of the C, which is going to be, I should say, the C which is defined on the top on the data block. And now that's all the changes which is required in order to add to our parameters block when we just add 1 level of the hierarchy. If we were supposed to add 1 level of the hierarchy, for example, with the gender of, I should say, the observation, if they're just going to be male or if they're just going to be a female, there should have been 1 more argument here. There should be 1 more matrix and 1 more vector. For example, we could have defined the matrix as matrix C, then it should have been a matrix for those changing slopes and intercepts, and also a vector which defines, I should say, the standard deviation of 1 more added level of the hierarchy. And that's all the changes at this stage, because we added 1 more level of the hierarchy. That's all the change, all the change which we need to just incorporate for the parameters block. Before, in case we lose it, I make sure that to save my work. Also, there is 1 more important block, and essentially the very last block that we are just going to incorporate our change before we just go to the model block, and that's going to be for the transformed parameters. And we know that in this case, when we add 1 level of the hierarchy, we have 1 changing intercepts and 1 changing the slope. As before, we can divide our work to say that, okay, at this stage, I'm just going to only consider the changing intercepts, And when we move on at the next stage, I'm just going to add one changing slope. But when the level of the hierarchy increases, we just incorporate both of them at the same time together. We say that, okay, when we add one level of the hierarchy to our model, which it shows that, for example, what stage of the Alzheimer's are participants who have been diagnosed with the Alzheimer and dementia they belong to, we look at that level as both at the same time random intercepts and random slope. And that's the strategy we're just going to have right now. Then I'm just going to incorporate into our model both the random intercepts and random slope for one added level of the hierarchy. In order to do that, I know that I can just go with this one, add one more level of the hierarchy. It becomes W. I know that for the intercepts, when they have the random intercepts, I look for those random intercepts as they belong to row number 1. And I'm just going to go ahead to add CDR, but the CDR which is going to be iterated with the levels which they have. I previously, for all the things which I defined here, for the n, I defined IK, I'm just going to add, and also I had J for the replicated values. I can just go ahead, define it with the L. Then I'm just going to, at the end, just go back to define another for loops for the L. Now, at this stage, I'm just going to define different components there, and you see if there is an error, this error notifies you that there is no L. I'm just going to define the stage, the loops for the L, after which I'm done with adding one arguments for these ones. And also, within the parentheses, now we have one more level of, I should say, variation, which comes from another, I should say, hierarchy level, which is going to be the W. I know that the randomness of the slope comes with the row number 2. Then as a result, I pick up the number 2 row, and for the CDR, I'm just going to go ahead, iterate it within each level of the CDR which they have, which it was supposed to be the L. And that's essentially, by doing that, I added one intercepts, random intercepts, changing intercepts, or varying intercepts, depending on what stage of the Alzheimer, by adding one more level of the hierarchy into our model, and also one components for the random slope of adding one more level of, I should say, a hierarchy, which was a CDR. But I emphasize once more again, when we defined at the parameters the matrix for the W, and we said that it has 2 rows, the first row, which I have here, refers to the random intercepts, and the second row refers to the random slope. Now that I'm here, I have to just, because still I have the error pops up there that it says that the variable L does not exist, I'm just going to solve it by adding one more level, I should say, of the 4. I'm just going to for L in 1 to C, because C, that's the level of, I should say, the the levels within the CDR level. And I'm just going to open the curly brackets, and I know that I have to also close the curly brackets somewhere at the end. And you see that all the things that we needed to do for the transferred parameters block is added, and I make sure that to save it before I just go to the next step in order not to lose anything along the way. And you can guess that if I just was supposed to add one more level of the hierarchy, for example, with the education level, then I have defined appropriate, I should say, parameters, I should say, with the parameters and the data block. The thing which I needed to add here was that to add one more level of the 4 and adding one intercepts and one slope to my model in order to add each level of the hierarchy. And you can see that the systematic approach we follow when we add step by step the level of the hierarchies to the previous model. Then by that methodology, you can add as many as levels that you desire, depending on the power of your computational power of your computers, because some of them, they are computationally extremely expensive. And now, I'm also going to my model block, which is going to experience some minor changes. The changes which I'm just going to have for the model block, it's going to be only for the priors which I have. The model is going to remain the same. The normalized whole brain volume bar, because it has been defined at the transfer parameters, it's not going to have any changes. However, and also the sigma isn't going to have change, but you can think of to add the priors for, I should say, for your double. You can leave them blank, and by doing that, you imply that you are incorporating the flat priors, which they are weakly informative priors, and by doing that, you vaguely introduce some, I should say, information about the things that you have, about the data that you have, and you let the data speak for itself. But also at the same time, for the sake of demonstration, I can give some priors for the W1, which refers for the priors for the changing intercepts. I can have it as a normal. Now we are looking only with the normal distribution. You can think of the other distributions. Sigma, we have sigma W. We introduce that sigma W at the parameter block, and it's going to be sigma W1. We can add the block. I can add a description that it's going to be the prior for the random intercepts of the CDR levels. And also, we can define the W2, which it shows the randomness of the slope. And also, we can think of it as a normal distribution, which is centered with the sigma W, which is the standard error for those ones, for 2, which we say that this is going to be the prior for the random slope of the CDR levels. But however, what are going to be the sigma W1 standard deviations for random intercepts within the CDR levels, and also sigma W2, which is going to be the standard deviation from the random slopes within the CDR levels? What are they? Either we can just define them as what we did before. For example, we define with any distribution like the Cauchy, another normal, or any other distribution like the gamma. Or we cannot define them. By not defining them, we are incorporating, as I said before, a weakly informative distribution, which is going to be a flat distribution. At this stage, I'm not going to introduce any distributions for the sigma W1 and W2 and let it to be the flat and the weakly prior distribution. You can define any distribution you want as a Cauchy or gamma or any other distribution. At this stage, I leave them blank. By incorporating that, they are just going to be defined as flat priors. I'm just going to save my block. By doing that, it means that I have defined whatever I needed. Now I'm just going to go to, and the likelihood is going to be the same, and I'm not going to have any changes for the generated quantities. And we assume that the generated quantities remain the way it is, because everything is going to happen. We have the normalized whole brain volume bar, it's the replication, and the replication has been also, the bar has been introduced before. At the transfer parameters, it carries the change to itself. And the sigma, we have defined it before as a standard deviation of a model. And the replication has been defined here as a new object. At this stage, and as we have saved the file, you see that by adding one more level of the hierarchy to our existing model, we needed only to incorporate a systematically minor changes to some of the selected blocks. Then by the thing that you learned, I hope that you can completely be comfortable in order to add one level of the hierarchy, one new level of the hierarchy to our model, which is going to be do that on the next tutorials. But That's the thing which we saw here. It's a kind of a systematic methodology to add as many levels of the hierarchies as we want. Now at this stage, we are done by creating a new, I should say, STAN file when we incorporate the variation within the CDR levels. And at the next tutorial, when we come back, we are just going to just execute this one and to see that what values that we're just going to obtain from the Hamiltonian Monte Carlo algorithm. Okay, I can't wait to see you on the next tutorial, and see you soon.